Okay. We'll get going since we're meant to be webcasting. I'm actually going to wait another minute because that clock up there is 29 minutes that I can see. So just in case it's on a network time. I'll go through the actual housekeeping for here. First of all, exit at the back, exit out here, and we go to the front of the building in case there's an actual fire alarm or that. You might see on your desks or that sort of thing a sign-in sheet, which is for CPD, continuing professional development for any attending engineers. It's become more important for the actual Engineering Ireland, or Engineers Ireland, to keep track of your actual professional development. So this counts for one CPD point. First of all, I'd like to welcome you here to Engineers Ireland. This is an event run by the Mechanical and Manufacturing Division of Engineers Ireland, which represents about 3,000 members, or 3,000 mechanical manufacturing engineers in Ireland. We also run the actual IMechE Republic of Ireland division, which is like 100,000 members worldwide. So we have a number of members here in the Republic of Ireland. So the purpose of the division is to provide opportunities to network and to learn of future trends in industry. And we have a great example tonight. We have Eberhard Klotz from Festo. He's head of the actual Festo Industry 4.0 campaign. And we have Barry Kennedy, who's CEO of Irish Manufacturing Research. So I'm going to ask Eberhard to go first to set the actual international situation, and then we'll have Barry. At the very end, we will have question and answers. So if you can hold on to your questions to the end, we'll have a question and answer session at the very end. So I'd like you to give a warm welcome to Eberhard.
Thank you, Paul. Thank you, everybody, for being here on site as well as online. I'm sorry for my German accent. Perhaps some of you would understand my German better than my English. When we get started with this Industry 4, it's a huge topic, and you can speak half a day about that. I brought with me today a couple of examples how the basic theory of Industry 4 could be made reality, how it could be implemented into machines, for example, in production systems. I have with me a few examples how Festo did first implementation steps in our own factory. As an end user, we are using these technologies now and try to improve our processes. And finally, I will also share a few examples on how we implement these new technologies into our product ranges, so that those of you who are in production businesses can also benefit from these technologies by using latest state-of-the-art technology. And by the way, our colleagues have a Festo van, a mobile, outside of front of the door. So later on, after the session, you are invited to visit and see some of the latest products and technology trends inside there. We have a website where you can find more details. You see it here, it's festo.com/IoT. First of all, when this Industry 4 discussion started, and it started in Germany 2010, the German government took a strategic initiative for the whole companies in Germany, for the OEMs as well as for the end users. It was reshaped and reorganized in 2015 to be adapted to latest changes in the market. And there are now in this so-called Platform Industry 4 team more than 1,000 companies involved, and 4 out of them are on the supervisory board level, being directly involved with Angela Merkel, our Prime Minister, and 2 of the ministers being in charge of that transformation change. And you see the 4 brand names up here. It is Siemens and SAP for the software and communication part for sure, the German Telekom for the telecommunication part, and it's Festo if it comes to applications, to make sure that also inside the machine something useful will happen with the new technology. There's a huge research project being set up where many things are still to be researched and to be developed. So not everything is ready for implementation now, but we already have a few things which we can share. And the second small chart indicates that there's a long-term 20 years roadmap for this Platform Industry 4 Association, where we think we have some things short-term to be implemented and some things long term. So don't worry if you are not yet finished with your Industry 4 projects. We are also not yet finished. We are doing step by step the implementation. And by the way, it's no longer a German trend. We have now a global situation where in Far East, in China, we have a governmental initiative which they call China 2025, where they now try to understand and to copy these Industry 4 mechanisms to their economy. And we have also in the US a different approach with the IIC, this Industrial Internet Consortium. We have in the US a lot of internet-based companies. They take a little bit a different view with big data and analytic tools. But at the end of the day, these ideas are all similar. We are networking components and machinery by using as much as we can web-based standards. And by doing so, we will find a lot of synergies using the data, understanding better processes in the future, and whether it's going to devices like these or whether it's our production systems, it is a new use of technology, and there are plenty of synergies available by using standardized communication technologies. Now, if we ask ourselves, where are the benefits of these Industry 4 trends? At least from a production company's point of view, there are 5 major topics being discussed. There are for sure more. If you talk to IT people, there are different perspectives on that. If you talk to business process people or HR people, there are different aspects on the topic. But from the production point of view, the first question is, in my business, is there any additional use? Are there any additional benefits in the relation to my customers? This is the first basic management homework you have to do. If the answer is positive, you will then figure out perhaps those 5 topics mentioned here. First is production. And many of these Industry 4 trends or technologies we are discussing now, or opportunities we are discussing now, they are not all completely new. Batch size 1 and customized products, individual products, in some industries, that's already a trend since 20 or 30 years, if you take automotive industry, for example. But there are other industries like food or textile or pharmaceutical, where lot size 1 is not usually in place. So these changes are different depending on which industry you are in. But assuming we are in a society where people demand more individual goods, we need production equipment that can do that in an efficient and effective manner. Now, the second is engineering processes. Festo had been involved in a couple of research projects in Germany, also one regarding engineering processes. And it turned out that there are 2 major aspects. One is the CAD engineering. Today we have in many companies CAD tools for mechanical engineering and others for electrical engineering, and perhaps another set of tools for simulation. And it would be a great idea if we have tomorrow one data package, one data container, where all that information is inside. And from that research project we had been involved, we now know already that if we get one day these packages harmonized, we can easily convert that data into a PLC program, and we get, now it's difficult to guess from just one research project what the synergies are, but we estimate that minimum half of the time we need today for all these tasks we can save in the future. The second aspect in engineering, the communication between the devices and between the machinery in future. Here we see a lot of synergies and a potential for improving business processes if we get that done by standardized communication. And here I will share a couple of examples later on in detail. Energy management, I would like to make a little bit shorter. For sure, if we use software tools to simulate business processes, to select the right dimensioning of pneumatic drives or electric drives, for sure these will consume less energy, there will be less over-engineering. That's relatively easy, and a company like Festo is supporting that since a couple of years. The second part, or the fourth part here, the logistic processes, there is a huge potential in several aspects. One is, if we better understand by big data analytics what the markets really need, there's a huge potential to improve these kind of business processes. And on the other aspect, our internal processes, our internal production systems with Kanban, with one-piece flow, can also be optimized if we have standardized communication in between our logistic systems and our production systems. I will also share a couple of examples how we use these technologies in our new factory. Finally, predictive maintenance, the fifth point here. again, that is something you can do already with existing technology. Yeah? The only disadvantage of existing technology is that there is a lot of sensors with a lot of interfaces. There's different PLC systems. There are different drive packages. If you bring that all together, it's a lot of programming. And if you would like to make a nice SCADA system, that's relatively expensive, as it's a lot of relatively manual work today. If we get that data standardized, we can transfer it to a cloud. We can make these visualization much cheaper and easier. And even more than that, we can easier analyze the data and make best use out of it. And I come to that point later on with some details as well. So these are 5 major points we already see is huge potential in a production environment. If we summarize that in a picture, it could look like this one here. If we agree that we would like to have modular production systems, they could look like this, with robotics or without. This depends on your business. And there is a connection to the logistics in-house, first of all. If we have done that in one factory, for sure we can do it in other factories as well. And if we have done our homework, we would be able to integrate also our supply chain in similar connections. Or if we are part of a bigger supply chain of somebody else, we have to be careful. What does it mean? Yeah? If my end user is modifying his production systems to a more or higher level of flexibility, how does that impact into my business? Now on PowerPoint, that's always looking relatively easy. For example, IT security, for sure that is a huge topic. It is not my topic of the speech of this evening today, but for sure we have to make sure we take that chapter serious and take our IT people into the discussions. And we know from our own move into a new building that the IT people and the production people don't easily understand each other. Yeah? If one is talking about objects, the IT objects might be completely different to the production guys' objects. Yeah? So there is a need help them to make themselves understood and to get a good communication. And if you look to the very right from your perspective, you see the interface to the customers and the logistics towards the customers. This is again one area where you have significant possibilities to improve and learn and understand your customers better if you have the chance to make big data analytics, for example, in an online shop. And we know from some industries already now, like automotive, that they make advanced use of these principles, because in an automotive production system, you have roughly half a year time delay to make a significant move to a new trend in the market or to a significant change in quantities. So these guys are now starting to analyze the online configuration of the car engines. And at least I can share how the Germans are doing this. The typical German man is configuring roughly 15 to 20 dream cars before he orders one. And now these people take thousands and 100,000s of their customers configuring these dream cars, and they see, okay, out of 20, he made 15 panoramic roofs as a try and 5 hybrid engines and perhaps 7 convertibles or something like that. And you get a clear pattern. And even if the guy is not ordering the panoramic roof now, you see the wish and a possible trend of the future. And this helps you preparing your logistics and your production equipment in advance. You can make use the data and improve yourself. And Festo is now also taking these online tools, these design tools for pneumatic drives and electric drives, bringing this into a consistent package in the future and trying to help you to make a best selection regarding energy saving, regarding the right performance of the products. And for our internal learning, we also try to understand, is there a trend towards smaller or bigger pneumatics, more electric drives, what else shifts in the markets might be. So there's a good usage. It looks relatively easy, but these dotted lines are really powerful lines of information and improvement for the future. Okay, that's a little bit the introduction. Now, if we want to do an implementation in our production systems, the idea in this Industry 4 trend is that we use cyber-physical systems. Now, there is no precise definition what a cyber-physical system should look like, how big it is, how small it is. And I have 3 implementation examples with me. They're all a little bit different. This one here is the most radical one immediately. If we would like to make a cyber-physical system implementation in a very lower level of a production system, going down to a cylinder, going down to an electric drive, going down to a simple or more complex sensor. The first idea of this type of physical system implementation is that you define a function. For example, a pressing function in case of such a cylinder, or a pushing function. And you put everything inside that makes that cyber-physical system run. So in case of a pneumatic cylinder, could be some valves, some sensors, some electronics, and an IP connection. Then this device can operate autonomous, completely autonomous. It can communicate to everybody in the world, whether it's this smartphone or any other computer worldwide which has an IP connection. Now, it doesn't make so much sense to start a cylinder somewhere in Germany here with the iPhone from Ireland or vice versa, but reading out diagnostics data could already be an interesting option. This is one package, one idea. Might be a little bit expensive, but technical-wise, it would work. Let's look for another idea. Oh, wrong direction, this one. If you don't want to go to the individual drive, you can go to a subsystem and group a couple of drives together and make your mechatronic system, your cyber-physical system there. Now, it could be regarding the functionality, a loading-unloading function. It's a small robot in your machine, SCARA or a Delta kinematics like you see here on the chart. And you define your cyber-physical system there, and you take a decentralized controller to make that one run. Whether it's inside cabinet or outside cabinet in IP65 control, that doesn't matter that much. In the Festo product range, we could do it, for example, in IP65 control. Now, the idea is to make flexible machines, modular machine concepts happen. These cyber-physical systems have decentralized control. That gives you a little bit of price offset for sure at the beginning, but you will reach more flexibility. And as mentioned earlier, the question is, where is the benefit in my business? Do I need this flexibility? Do I need the lot size 1 or 10 or what else it might be? And how do I reach target? If that's even too small, you can implement cyber-physical systems also on the level of a machine cell. And this is the other example, is a picture out of our new production systems, where we exactly did this kind of implementation. We used one controller per machine module, but inside each machine module, we have a lot of these subsystems as well. So we followed a double strategy in that machine, which leads to the fact that this kind of machine has 400 IP addresses. That is a significant change compared to the old machine, where maximum one IP address is in the control cabinet, which impacts your IT infrastructure in the factory, but also your maintenance people, your operation personnel next to such a machine. There's a huge change in these profiles as well. Now we did a test implementation of cyber-physical systems in one of our modular factories. The picture is now a little bit small up there. It's a modular cyber-physical factory our team in Festo Didactic is using to train students or pupils or big OEMs and end users in these Industry 4 environments. And inside that machine, there are cyber-physical systems on each stopper cylinder. Now, if we implement that, don't start reading the text, it's not necessary. I will explain it in a few words. If an intelligent workpiece in that machine is traveling along, stopping at the stopper cylinder, this stopper cylinder can give a direct call to the MES system, which is in our case an SAP system. We operated the machine in Hanover exhibition in Germany. The SAP host system was standing in Switzerland for that test. And we had been using OPC-UA communication, which is one of the recommended communication standards for Industry 4. And the stopper cylinder now is using OPC-UA to reach SAP, and they can make a direct decision now what to do with the workpiece, drilling more holes, painting it green, passing it on to the stock or something like that. And this trip took around about 200 milliseconds. Now, I'm not saying this is how you should design your machines tomorrow, but this gives you a feeling how strong the change, this disruptive technology, as it's sometimes being mentioned, is for the future. The control concepts can be really completely different. And if you invest IP addresses on a cylinder, on a stopper cylinder, in that scenario here, there's no PLC. Sorry for the PLC guys inside here. There's no PLC any longer in between. So this gives you a little bit of feeling. There is a strong power inside these cyber-physical systems for change. That cyber-physical system talk to each other one day, or talk directly to host computer systems. For sure, as you can see, 200 milliseconds, that's by far too slow for high-speed machines. That's by far too slow for motion control. So luckily for the control guys, there's still enough business for anybody in the market of today. But there's a power for change in a significant option for the future. Okay, there are many, many more things. The way how we exchange and work together with machines, with robots, will change also. We did some tests at our own factory with collaborative robot systems. That one here is 4 years old. It was the first one in Germany with an official permission by the bodies to be operated. If you took a look on last year's Hanover exhibition, Automatica Fair, the robot exhibition, more or less all robot manufacturers today have collaborative systems in their ranges. So within only 3 years' time, that picture changed completely in the market. So this is one indication how fast that trend is going on and how serious we have to be aware there are changes coming. There are also very easy examples available, like QR codes, which we are using, for example, to give you direct online information for a product if you scan that QR code, but also for complex product consisting of hundreds of individual pieces. You have one QR code, you scan that, you get all the 100 products immediately documented, all technical data, all CAD drawings are available. But even more, you can order spare parts with these QR codes. And then it's not only talking about technology, then it's also change in business processes. If your people in the company scan with a company iPhone these QR codes, is your purchasing department already prepared to support such a process, which is today the one and only who is ordering something? And if the guy is using his private phone, how long does it take you to make sure he gets his money back? So this is technology that is available, and if you are interested in more details, I would like to recommend you ask me later or my colleagues. There was a huge test done in Germany, at least, to test this OPC-UA communication in a project called Smart Factory. This was supervised by a university in Kaiserslautern. That is where the KL comes from. And this Smart Factory research project was an interesting one. Festo was involved in that as well, because the question was, if we use machine modules from different suppliers, is that communication stable if we use OPC-UA? And you see these machine modules, it was a cooperation in the first year with 7 companies, second year with 11 companies. And we had that machine run in Hanover exhibition several times. We stopped the machine, took 2 modules out, mixed them, and placed them back again to the machine and switched on again, and demonstrated what will happen now. And by just programming or using 12 variables, OPC-UA variables between these machine modules, we'd been able to establish a communication. If the intelligent workpiece was traveling along, it recognized, oh shit, my neighbor. So I have to go to the overlay station now, and to keep the sequence, go back this way, and then continue the process. Now, I'm not telling you this is how you should design your machines tomorrow, but it gives us a good feeling that these kind of self-adapting algorithms in the flexible production environment one day really will be possible, and it's not so complicated to make it happen. And Festo took the learnings out of these Smart Factory projects and transferred that on the one side into our cyber-physical factory of this Festo didactic team, making sure students and pupils can learn, but also professionals, on how to deal with that new technology. And on the other side, we specified for our own production equipment the same philosophy to make a modular production system. And I think this is a good point to point out that for the moment we have this OPC-UA communication standardized and recommended as one of the Industry 4 standards. We have no recommendation between machine modules. So in case you would like to plan something yourself, you have to do your own specification or to agree on a specification with your customers, depending on where you are in the supply chain. So that's for the moment the communication status. So at the end of the day, Industry 4 can be relatively easy. You have a product, you add some decentralized intelligence and standardized communication. Can be as easy as that, at least from a technical point of view. And then, if you have that done, similar to the mobiles we all know and use, and the smartphones, then you can add a lot of apps and services and new technologies, new business models. That's up to your fantasy and your business environment, what you do there. And as there are many companies doing the same things, you can use a lot of already existing tools. You have not to reinvent all the wheels yourself. Yeah? If there is analytic tools already available in one of the big cloud providers, you can use these analytic tools already. So there are the synergies for the future and the great potentials. Now I would like to share a couple of examples we are doing in Festo. Finally, this is the communication overview. OPC UA is there. It is now going to be implemented in the Fieldbus communication systems. There is IO-Link also available as a very good supportive infrastructure for easy sensors and small remote I/O devices. And what we are missing for the moment and what's pending is the CAD standard. We are working on that. It's not yet ready, but the automation markup language, this AML association, is one of the most promising candidates which we see to become this CAD standard for mechanical, electrical, and simulation tools in one. There's a pilot test, by the way, this year, done in an automotive factory, and if that is technical-wise stable, then we will go for the standardization. Okay. Festo was lucky to move in a new building 2 years ago. Our new technology factory in an area placed next to Stuttgart, which is called Scharnhausen. And we gave ourselves 4 major targets before we moved in there and did the planning. One was flexibility. We believe that our customers demand more individual products in the future, and therefore we prepare ourselves to react to this kind of trends. Second was we tried to make the best out of process improvements in the factory by networking the machines with these Industry 4 standardized tools. Third, as energy is, at least in Germany, very expensive, we had a big focus on energy saving actions. And finally, we try to integrate as best as possible our people, because we believe we need all these people to make the growth in the future happen. And sometimes we have discussions about, is this a technology laying off a lot of people? We believe if you have a clever concept, if you train them, there is no risk for the people. You can grow and make your growth happen by integrating the people. The first thing is this machine you have already seen. I make it now a little bit shorter. We have analyzed for ourselves that flexibility is not always lot size 1. If you produce 1 million parts, lot sizes of 10 to 10,000 can also be an appropriate answer. This depends, as already mentioned, to your individual business. This was our decision to use 10 to 10,000. Now, if you ask for benefits of such a flexibility concept or an ROE on that, that's a little bit difficult to grasp, because it's not so easy to evaluate the value of flexibility in 5 years' time. But if we compare such a machine with existing old machines, might be roughly 15 years old equipment, the flexibility increase is comparable, half an hour, some hours in the old machine with mechanical adjustments, 13 seconds now. Or if I have a technology change tomorrow, let's say the second module here is doing some screwing today. If I get a better technology tomorrow with gluing or 3D printing, I just exchange such a module, which is completely independent with a decentralized control. I can do pre-testing of such a module, and then hopefully in one afternoon, I'm adapted to a new technology. So these are benefits regarding flexibility, which you can gain if you have standardized interfaces and standardized communication in the machine, and you can even buy the modules from different suppliers. So that, from an end user point of view, is a great advantage. From a machine builder's point of view, can be seen as a disadvantage. So you have to be competitive to stay ahead and to deliver all the modules. This is a new machinery example. Existing machinery, old machinery. For sure, we're coming from an area in Germany which is called the Swabian area in the southwest in the country. And the Swabians are famous for protecting their money. So if the 10-year-old machine is doing a good business, why is there a need to buy a new one? Just make the old, take the old and bring it to the new factory. But our question was, if we would like to optimize our business processes, how do these old machines communicate in an Industry 4 environment? And we analyzed those areas where we thought it is valuable for us to update these machines and upgrade these machines. And our answer was that we will take all shop floor KPIs, performance data of these machines, and convert that into an OPC UA frame. And second, to take the energy data, make energy transparent machines, and use that data to optimize the energy consumption of the factory. Now, we are SAP users, and those days SAP launched a new plant connection module, software module, where you can directly feed in OPC UA data. So for us, it was relatively easy now to bring OPC UA data directly to the MES system and make better decisions and better process optimization. If you would like to update an old machine, you can modify the PLC program, which is, if the machine is 10 years old or even older, sometimes a little bit of challenge, because the machine builder's programmer might not be available any longer, or if he forgot what he programmed those days. So we decided we add a small PLC next to the existing one, and we add those sensors we need to make energy transparency in the machine. So these retrofit projects had been our invest. We had been partly using Festo controllers, Codesys controllers, or other brands. If there is already, let's say, a Beckhoff or a Siemens inside the machine, we also choose other controllers, also to learn how these new technologies can be implemented. It was an investment roughly 3,000 to 5,000 euro per machine. Now, if you ask me what did we get out of that, let's start with the number 2, first of all, energy peak management. If you have machines and not knowing what they are consuming over time, you have a maximum load, energy load of the machine, and you adjust these maximum peaks together, and you pay that bill at the electricity company. Now, if you have full transparency, and you switch on in the morning at 6, your machines, all machines, by statistic functions, these energy peaks can anyway add up to a big load. Now, in our case, we are in a lucky situation that these machines are independent. So there's no need to switch them on all at 6 o'clock in the morning. So let's have a few seconds or minutes buffer in between and optimize the energy peaks as good as possible to get a smooth average. So this was one of the actions we did in the new factory, but therefore you need the data. Otherwise you cannot do these kind of optimization routines. It's a relatively simple thing. We also invested for sure a lot in solar panels and reuse of heat, different concepts. Altogether, we had been able to save roughly 1/3 in energy compared to the old factory, which is around about 10 gigawatt hours. That is in German pricing models already some million euro per year. That was the energy part. Now regarding business processes, we optimized our machinery in 2 dimensions. The one is that we had been asking ourselves if there is, for example, 5 machines treating raw material and we have a breakdown by 10%, if one is going off for any reason. In the old days, we had still producing with the other machines a lot of pieces, and to get rid of them, we need a night shift or an extra weekend, which is more expensive. So if you have such a bottleneck and the machines are networked now with the same standard, you can immediately reduce the others as well and just feed through the line what is possible to be processed in the bottleneck area. Another example how we use the data now and to optimize the business processes is, and I hope you can see red dots on the picture here and some green and some yellow. This is something specific. We give a guarantee to our customers that for some of our products, if you order until 9 in the morning, you get a customized product until 3 in the afternoon. At least that's when we ship it. And the red dots indicate that machine cannot fulfill the workload of the day. The yellow one will do good, and the green one easily. The green one can also be an empty machine, no work today, which is from a commercial point of view not that nice. So now we have clear data available, and we can now make optimized decisions where it is worth to invest in new machinery or in more flexible machinery. Try to keep that picture in mind, because there is another very interesting project done, which is mobile maintenance. Mobile maintenance is iPad for each maintenance person. And instead of walking all the time back to the central maintenance office, these people now have all the repair instructions on the mobile information and all the error messages as well. They can now repair the machines quicker. They can balance their workload easier in the team, making quicker decisions. So the overall OEE of our factory increased. I'm not allowed to tell you how much, but it is okay. And the ROE of that project is below half a year. That is close to a sensation. It's really good. okay, it was relatively easy for us. We had all documentation already on SAP, so that it was only copying that to an iPad, including the error messages. But now we can go even further, and that is what something of these interesting Industry 4 mechanisms, bringing data together from different sources. In energy peak management, we compared building data, solar panels with machine data. Here, we can tell the people, hey dear, if you have 10 error messages from the machines, in old days they did first in, first out, just the sequence. Now we can tell them, hey dear, listen, your machine number 5 or your error message number 5 or 7 is coming from a bottleneck machine, these red ones from the other picture, and optimize our value creation by just optimizing the sequence on how these machines get repaired. So there's a lot of room for improvement in the production processes, in the logistics internally, if these data is matching together. These are a couple of examples. A little bit running short in time now. Let's switch to at least 2 or 3 slides how we implement that into products. I mentioned already that chart, bringing decentralized intelligence to the products and the standardized communication. And for easy sensors, for easy drives, for easy pneumatic cylinders and or electric drives, we use IO-Link in our portfolio to make sure we can support with a very good data structure these kind of supporting actions. But even more interesting is the more complex products. And I'm sorry, that chart is a little bit complex. Let's start in the lower right side of the chart. We are coming from these pyramid structures from the last 25 years, where we have Industry 3, let's say, classical hierarchies, and we are supporting that with our valve terminals. Now, taking these valve terminals, I already mentioned, they are flexible, they are modular, and we are able to add to the field bus communication a decentralized code-assist controller. So it's up to our customers to make their own decision. How long do I would like to go with Industry 3 inside the hierarchy, and when is the starting point when I would like to upgrade my systems for these cyber-physical systems with decentralized intelligence. Then you just take the same infrastructure, no changes to the mechanical infrastructure, just adding this control. For sure, then there is change to the control concept, for sure. In addition to that, we launched last April an IoT gateway, which we can place on these valve terminals, but also as an extra product. And these IoT gateways are taking OPC-UA data from several devices and convert that to AMQP. And AMQP is one of these web-based protocols which you can directly feed into a cloud, whether it's the Siemens or the Allen Bradleys, Rockwells, or the Beckhoffs or SAP HANA or any other, doesn't matter that much. And this concept is now available from different manufacturers. That is a philosophy many PLC manufacturers are following, that you take OPC-UA data as a standard and convert it into web-based protocols. Now, at that point, such an IoT gateway has to make sure proper IT security, because at that point, you're giving your data to a cloud, to the outside of your company perhaps. So here, IT security mechanisms are important. And our device, for example, is doing the handshake, the security handshake with all the devices which are connected automatically, exchange of certificates and these kind of stuff. And we also added to our product a hardware switch, which has 4 important functions. And the first is off. So a physical off. And this is the point. We're now talking a lot about technical solutions. But if we as a Festo sell a component to a machine builder with an internet connection, the machine builder gives that machine to an end user. These 3 parties, perhaps the 4th one, if it's the cloud concept, they now have to agree on how to use the data. Who is available, which data is available to which person or to which company? Is it free of charge? Do we would like to see some euro rolling around here? They need a culture of trust for that. And that's new. It's not only the technology which we have to have in place. We also have to have a clear agreement about the data and who is doing and who is reading what. Now, if we would like to have the diagnostic concepts available, the next position of our switch is read only. That means you can get out all data out, but no access from the outside, which is also for many people an important factor. And if you would like to have remote assistant concepts implemented, for sure, then you have to write and then IT security has to make sure these rules are handled properly. There's much more to say to that chart due to the time restrictions, I would say. That's it for the moment, and we take a look into a cloud concept. If you have the hardware finished, and this is now the modular concept Festo is following in that area, we have so many different customers. There's no one-fits-all solution. Everybody will do that a little bit different. We can sell these hardware concepts, and that's fine, and you do the programming all yourself. If you are no programming experts, we can give you an additional support. We will offer for our subsystems, our mechatronic subsystems, individual apps that make you these kind of visualization. So with just one short snapshot, you see the overall current consumption, the overall pneumatic values inside the circuits. And if you take the second screenshot in the middle, if you drill down one layer, you see all three axes of such a gantry, the mileage it did, the turns the motors have done, the temperature the motors have. There's no additional programming needed for you. You just take that app and the value out of that app. And this is exactly the point now where you have a good opportunity to optimize your systems, again with these cloud concepts and the analytics. Just one example, if a motor is getting hot, a typical machine builder of today would say, okay, I have some sensors in my machines, I see the motor is getting hot, but I still don't know why. Well, there might be many reasons why a motor is getting hot. And if you don't program that in yesterday's technology, you will never have a clue what's going on in your machine. Now in a cloud, there is no need to program that. You just store all the data, and if the motor is getting hot, you can ask the cloud, what else happened at the same time? And perhaps you get a feedback, your current consumption increased at the same time. So this could give you an idea, perhaps that's a short circuit in the motor. If you get a feedback, I lost mechanical speed in the machine. This might be an indication for a mechanical problem in the axis or in the application, and the motor is working against the mechanical block. So such a cloud feedback and analytic tool could give you additional valuable information without any programming. So this is one of the benefits where Industry 4 mechanisms employed in such an environment really can help you improving your machinery, reducing downtime, increasing OEEs. Now this is the basic concept, and the advanced concept could be that deeper analytics inside the equipment, electric drive, pneumatic drive in our case, could look like that. With a recommendation in Germany from the Machine Building Association on how to treat diagnostic data. What is the green status, what is the yellow, orange and red? And many companies, also Festo is following that recommendation. And we could reference with our drives to such an evaluation. And now it's again the question of which level of service you would like to get from a company, for example, like Festo. You can get another app and then this kind of feedback. Just a counter and an indicator where in the green field is my drive and when do I reach the yellow area. If you buy the picture only, it's up to you to make the decision what you do. But we can agree on additional services, so we would be able to send you an email before it's getting yellow. We send you a service technician if you like that, or we send you a package every Monday morning or every first of the month, what you should replace the next couple of days, and then you make your maintenance planning. And this again is not only the technology, it's again the teamwork in that component supplier, machine builder, end users network, how we would like to organize our work together by using and exploiting these new technologies coming here from Industry 4 mechanisms. These are a couple of examples. We are using our knowledge now to build subsystems, not only components, but let's say handling systems, gantry systems, welding guns, servo presses, any kind of applications, and try to make a ready assembled kit where you have the mechanics, the motors, decentralized controllers inside, including some software packages to start and operate these things just by using parameters instead of programming, making your life easier in implementation, in operating that. And if you take the Festo controller, they are all using codices, they are all using OPC UA interfaces, so this is a minimum set, which is Industry 4 ready. Yeah? And you can implement that into your strategy if you like to do it with a Festo concept. That's it from the hardware and software point of view. There are many more products. I think we will be fair to the next speaker. and stop it here. We have a long-term vision in this Industry 4 where we use bionic learning network. And I have an example here with me. This is a bionic ant, a bionic robot. And I will show you a short film and tell a few words to that. Let's see whether it works here as planned. Okay. We built these robot ants and tested collaborative mechanisms between machines and robots with these as one of many, many Industry 4 projects. So asking ourselves, if I give a robot a task, and this ant's task was, if they come across the blue object you see in the film, they should push it away. But the trick was, the object was too heavy for only one, so she needed assistance in the team. And these ants are completely equipped robots. They have stereo cameras, 3D sensors to know where they are, and they can communicate to each other. And we have a shared target programming on these ants. The IT experts call that a multi-agent system. And so these ants, if they cannot push the object, they can ask for assistance, and then 3 together can move it. And whether 2 of them now are going forward and 1 backward, or vice versa, they are organizing themselves in the team. So this is one of the projects we have made as a study, whether one day we might be able to have self-adapting and self-organizing machine algorithms or robot algorithms to optimize work like that, which is one of the long-term visions in the German government's roadmap, by the way. And this bionic project here demonstrates the answer is yes, we might be able one day to do that. To which degree we want to do it is a different discussion, and this we have to do as a social discussion as well. This is one of the projects. There are many, many more, and we are happy to answer more questions later on in the discussion. Thanks a lot.
Thanks, Eberhard.
Sorry for consuming a little bit more.
I'd like to call upon Barry now, who's Chief Executive Officer of Irish Manufacturing Research. Need to get into your one. There we go.
Good evening, everybody. Thank you very much for hosting me here this evening. I'm delighted to have a chance to talk to you about Industry 4.0 in the Irish context. This afternoon I was trying to, or early this morning, should I say, I was trying to put together the slide deck, and I came up with a large number of slides, and the couple of folk in work I was talking to about it said you'll never cover them in 30 minutes, so I kind of figured, well, 30 slides, a minute a slide each, sure, that's manageable. And then I decided, well, actually, maybe I need to do something about this to make sure I hit that target, and I need to get a clock, and I need to keep an eye on the clock and watch it cycle down so I can make sure I stay on track. And then I realized that, you know, the way I talk, I'm likely to linger on some slides a little bit longer than I should, and go shorter through others. And I'll get feedback from the room about if I think people are getting interest out of any one slide or not, and I might stay a little bit longer on it. And I'm making those decisions during the course of this presentation. Industry 4.0, if you like, is a bit like that in the context of what it's doing within manufacturing and industry, except it's based on cyber-physical systems, compute power technology, and sensors talking from factory floor into the compute power technology, making decisions and feeding back information. It's the industrial Internet of Things. It's connected sensors and objects and things together up through a compute platform, making decisions, helping us to drive productivity and manufacturing efficiencies within our manufacturing organizations. It's a significant inflection point, a significant change for industry, and it's nothing new. In fact, if you heard from our last speaker in connection, you know, with the technologies, a lot of those technologies have existed today. So what's kind of changed? One could argue that Industry 4.0, in fact, it's just a branding. It's a pulling together of technologies that we've had there for quite a long period of time to drive this kind of inflection or this change. But it's a little bit more than that. Compute power has changed of recent times with the development of new microchips, the development that's taking place in companies like Intel. And the simplification and reduction in cost of technology that companies like Festo have delivered is making it easy now for manufacturing companies to engage in this whole thing about the connected factory. Companies like Intel have been doing it for the last 20 years. They have accepted they spend $2.5 billion setting up a factory or a facility. Now this compute power, these technologies are within reach of the small, medium manufacturing enterprise. And that's really what Industry 4.0 is about. And today I'm going to talk to you a little bit about that in the context of what it means for Ireland and where do we stand and where do we rate. During the course of the presentation, I'm going to cover a few slides and never miss the opportunity to do a little bit of advertising about the kind of work we're doing ourselves within our own research centre. I'll be doing that. I'll talk a bit about Ireland, but I'll talk about it at a policy level as well, and not just around kind of the technology challenges. Okay. So manufacturing in Ireland, why do we care about it? Why would you care about Industry 4.0? Right. So the latest figures from the IDA would state that we've got 36.7% of our GDP is accredited to manufacturing. Now, one can argue about these figures. There's some debate going on about whether it's really more like 25% or 36%. The fact of the matter is a very large proportion of our GDP in this country is around manufacturing. It's important. 231,000 people are employed directly by manufacturing. We need to make sure we protect it and we grow it. It's taking us a long time to get ourselves into this very good state, and we shouldn't let it go. It was an anchor while we were going through the crisis over the last number of years. It kept us afloat, and it is very important that now, with the more recent threats of things like Brexit and other foreign policy changes by other governments around the world, along with technology advancements and the rate at which they're coming in, changing the face of manufacturing, we need to be doing everything in our power in this country to make sure we maintain the position we have. It is crucial. Okay. Technology is changing. It is game-changing for businesses, and it's disrupting like nothing we've seen before. Traditional business models are being threatened. Traditional jobs are changing rapidly, and especially with this whole physical to cyber systems conversation that we've just heard about earlier. So are we ready in Ireland? Interestingly enough, the Roland Berger assessment of the Industry 4 readiness, where do different countries sit in regards to their ability to be able to deliver on the Industry 4. Surprise, and that was a big surprise to myself, Ireland's sitting right up there as being in the front runners. Under two particular headings, industrial excellence and value network are the two thematic things that feed into this particular index. I was a bit surprised because as I walk around industries in this country, I find that they're not very well connected. In fact, I would class them as being quite poorly connected in terms of automation and this Industry 4.0 from sensor to cloud capability. So why is it that Ireland got this particular rating and was seen as being that? Well, one of the reasons is because Ireland is seen as having a workforce that's very adaptable and willing to change with new technologies. It's seen as being having a very highly educated workforce, and it's seen to have a very strong foundational stone, albeit it hasn't done the whole thing yet, but it's kind of teed up and ready for action. So we're in a good position. So we have a very strong manufacturing base, and we're in a very good position to engage with it. What we need to have is actually leadership within the country, leadership at a political level, and leadership at an industrial level. The CEOs and business leaders and industrial leaders in this country need to take that leap of faith and engage in this thing here. The technologies are ready for action. The companies like Festo are ready to come in and help and support us. Okay, this is just a little bit about Irish manufacturing research, and my slide deck is unfortunately after jumping in sequence there, I had to make a last minute modification there just before I started my talk. We're very well connected in across Europe into a whole bunch of I guess, bodies and organisations to help Ireland understand what our position is and what we should be considering doing. What's the rest of Europe doing? Where do we rank relative to the rest of Europe? And can we engage and partner with companies and institutions across Europe to help solve this big challenge of Industry 4.0? So we as an organisation have got a lot of connections there. We're very willing to help and support the manufacturing base in this country. This slide should have come first. Yeah, I'm from an organisation called Irish Manufacturing Research, but we're under an umbrella called Advanced Manufacturing Ireland. It's made of three parts, 2 business networks and 1 research centre. And our game is to try and enable Ireland as a global leader in advanced manufacturing through the networks. So it's 1 research centre, 2 business networks, trying to drive change to make manufacturing facilities more productive and energy efficient in this country. What do we offer? We offer consultation, technical and business analysis, and manufacturing assessments under a number of headings. Industrial IoT, Industry 4.0, another way to frame it, collaborative robotics, energy, data analytics, by way of example. We help companies understand from a market point of view where the opportunity is, what the cost of ownership would be if they were to bring in some of these technologies, what the new business models might be, and what their readiness levels are. A lot of companies don't know, when they say Industry 4.0, some will tell you they're very Industry 4.0 ready, and others will say they're very bad. But actually, in reality, most companies in Ireland don't really have a clue. They don't know where on that scale they rank. And so we need some standards where they can reference off to know exactly where they stand, so they need what they need to aspire to do. We offer research and design and optimization for manufacturing. We do a lot of research in this area. We've a research team of over 30 research engineers who all come with a lot of industrial manufacturing experience. We deliver decision support tools, modelling of production lines, and data analytics by way of example. And some exemplars of that are up there on the screen. Now, the animation isn't running here in the background, but the top part there is a modelling capability which we've delivered for companies who are trying to design parts in additive manufacturing or 3D printing. And it's a tool that we've designed that simplifies what's required if it's the case you want to redesign a part. Because today it can be quite a complex task having to hire in design engineers to design parts for a customer. And so we're delivering tools that simplifies that process for you. The bottom that you're looking at the screen is a tool that we've delivered it's a decision support tool for manufacturers. So if you're trying to understand what's going to happen in your manufacturing line if a machine goes up or goes down unexpectedly, or maybe you bring it down for a minute for engineering work and you're not going to have it available for that particular shift, what's that going to do to your production outs at the end of the week? This capability we've delivered uses very high-end artificial intelligence and algorithms to help you make decisions about what the right way might be to run your manufacturing facility. There's an example of some of the kind of research we do. We have R&D test beds and an Industry 4.0 pilot line being built today in Mullingar. A little bit more about that later on. It's the digitization of manufacturing. So it's a playground or a sandpit where manufacturers can come and try it out and test and de-risk and demystify some of these inflection points or these challenges that they're being faced with. And again, we're looking at that under a number of headings, not just Industry 4.0. We're doing it for additive manufacturing, we're doing it for cobotics, and we're doing it for energy efficiency as well. We do a lot of training as well. We do specialized industrial courses for manufacturers. We go down into your factory and we'll do some training courses there. Or we'll do other types of courses where we pull industries together and we'll do introductory courses or advanced training courses in the topics as I've just described earlier. Here's an example of one of the capabilities that we have delivered, not too unlike the system that has been delivered by Festo for maintenance on the line. We've delivered a system called the Workplace Knowledge Management System. It's know-how, know-now. It's a little bit different though, in that working with psychologists, training development specialists, we have delivered a solution here where technicians and operators on the floor can quickly record tacit knowledge, nuggets of information that they've done, little tricks of the trade in terms of how they can solve particular problems on the floor. And they can upload it very simply into a system. If you think of a YouTube, Facebook or Amazon on steroids for manufacturing, that's kind of what this is. And we've built it on to work on multiple different platforms. It doesn't care about the file formats that you put up there. And it has a very smart artificial intelligence and search engines on the back of it that will intuitively pull up these knowledge nuggets as and when you need them. It does association of content as well. So if you're looking at how a valve might be assembled at 3 o'clock in the morning when you're trying to do preventive maintenance, it suggests sort of content. It tells you that the last 10 people who assembled that valve also looked at how you cleaned the valve. And these knowledge nuggets are done in certain sizes of video, timing on the videos, not too big and not too small. The video clips shouldn't run for an hour because a technician or an operator at 3 o'clock in the morning will never look at it. But it needs to be not too short, that you have to be stringing multiple video clips together. So working with psychologists about the experience and trying to create a very good and high-end experience for technicians and operators, we've delivered this system. And if you're interested in learning more about it, delighted to show it to you afterwards. Okay, let's look at this. Look at the past as an insight to the future, okay? And I'm going to talk about Industry 4.0 in the context of business models. During the first industrial revolution, and most of you have probably seen, the four industrial revolutions, so I'm not going to linger on those points. I just want to try and bring it in from a slightly different perspective, though. The first industrial revolution, power belonged to those that controlled the means of production, those who had the wealth. That's in essence what happened, right, during that the first industrial revolution. When you look at the second and third industrial revolution, it was the big always beat the small, the big multinationals, the big corporates. An inflection point happened. This fourth industrial revolution, where technology broke all the rules. And you can see a lot of household names up there and the business models that they created. And most of them were created from small back bedrooms or from small university lab environments. And look at the kind of size of facilities that and companies that they've delivered today. But what they've done is they've disrupted business models, traditional business models. They created new ones, but they've also disrupted a lot of the traditional models that existed. And if you look at a couple of other players there, companies like Airbnb and Uber, for instance, in terms of what they've done. You know, Airbnb, as you know, the largest hotel chain on the planet that doesn't have a building, doesn't own their own hotels, and Uber, the largest taxi firm on the planet, and doesn't own a taxi. Okay, so they completely upset the business models. We need to be conscious of that in Ireland in the context now of industry and manufacturing and what we've been doing. What's going to happen? So let's look at this in the context of those who do and do not innovate or adapt to these emerging technologies. If you look at in Detroit and the car manufacturing, there was a big focus there, protection from a union point of view around labor versus automation and robotics. And because they didn't move with the changing times that existed at a point in time, they lost the manufacturing base. It went to other regions where more automation was introduced and the cars were produced at a much more cheaper and affordable rate. They had to do that in that context because in Asia they were automating their facilities and they were reducing the cost of manufacturing. Germany never stopped. It continued to innovate and is a global leader today in manufacturing and continues to be a global leader. The UK, they stopped, realized the mistake that they made. They focused on the service industry and have now re-emerged and they're trying very hard, right? If you look at some of the investments that they've done recently in the UK, particularly the catapult centres and the MTC centres, it's extraordinary how they've managed to turn that around when they put some focus, real focus into it. But they really have turned. In California, if you look at it, what they did there, the ICT industry, I mean, California was known for its fruit and veg and climate. But they adopted those new technologies, and now you have the economy in California bigger than most countries. This is just an example of something that last week I was over in Turin, and I had the fortune to meet up with a company called Rolls, ROLD. They make the components for the locking mechanism in most of the washing machines around the globe. They make 50 million units per year. They're manufacturing it in Italy and they're exporting it to China. I was really blown away. I thought it all came the other way, right? It's hard to believe that they're actually exporting 50 million units and exporting it to China. Just extraordinary. And we were talking to them about Industry 4.0. And that company, as you could imagine, have to run a very different way than most manufacturing facilities might run, say, on this side of the world. They have to be very thrifty, and large investments they can't do with things like, for instance, Industry 4.0. So they've gone after this and fixed it using consumer products. They have reinvented or invented their version of Industry 4.0 using Samsung plasma TV screens like you see up there in the top right-hand corner. That's the reason why I put it there. That's actually on their factory floor. And they were showing us, it's publicly showing it to us, what they've done with respect to OEE measurement on their systems and machines. And they're transferring that data wirelessly onto smartwatches like this one here on my wrist. And so it's notifying the technicians and operators when they see something going wrong on their machines. But they're not going for ruggedized PCs at $4,000 a pop. They've decided to go with tablets that are costing them 100, 150 euro a pop. And they've said, well, if it breaks, we buy another one. So they're approaching the problem statement very differently, but they're not going to be left behind. They've realized that if they're going to survive in this game, they're going to have to really get somehow very creative about how they engage with Industry 4.0. But that's the way they've attempted to do it, by taking consumer products and doing it. It won't work for all companies, but for their particular set of circumstances, it seems to work. In our own case, in Irish Manufacturing Research, we're doing the same thing. If you look at one of our exemplars here on chilled water, we've delivered a chilled water optimization system. This is an Industry 4.0 project. We have got embedded microcontrollers hooked in and connected wirelessly to sensors that exist on the various parts of chilled water systems within large manufacturing facilities, relaying that data back up to an optimization engine and a modeling tool. And we are running and controlling in small, medium enterprise and large multinational, and controlling and improving their energy efficiency on that particular system by upwards of 30%. So within this country, we have the ability with the research institutions, not just our own, but if we look at some of the other research institutes, if we look at Tyndall and organisations like that, and some of the new SFI centres, which I'll talk about in a moment, this country has got a lot of talent, and we're well able and ready to engage in terms of deploying and developing some of our own solutions, along with the partnerships with companies such as Festo and bringing in the goodness that they have to help us solve these challenges. So to remain competitive in this whole Industry 4.0 space, there's a number of things. The whole cyber-physical system thing we need to engage with, or the Internet of Things as it's known, or the smart factory. We need to be thinking about decentralization in a lot of cases of the kind of work that we've been doing. We need to look at real-time and real-time capability and data transfer in real time and what that's going to do to our business models. It's got to be more service-oriented type approach that we need to be taking, and we need to be looking much more at modular type manufacturing that was already mentioned in the previous talk. What's changing? New competitors with radically new industrial business models are coming. Established companies are going to change their organizations, processes and capabilities. The traditional industrial boundaries are becoming blurred. And the supplier hierarchies are changing between the physical machine and the tooling suppliers and their industrial with the advent of these cyber physical systems. So the rules of the game are all changing. Who's controlling the game now all of a sudden? Like, for instance, if you think in medical device companies, it's not too far out when you will go to the doctor and you'll get a 3D scan of your hip or your knee, and that part will be made exactly to your specification. It won't be a small, medium, and large artificial hip or knee. It'll be one that will be made to your particular need. The surgeon will press print. It'll go to a 3D printer, probably in some local supplier, and the part will be printed and it will be brought to the hospital. So the rules of the game are all going to change, that whole business model and how it operates. We in Ireland, as these connected businesses are all starting to happen, really need to stay vigilant and connect into it. So how do we become ready? We have to start at policy level. First of all, I think Ireland needs a policy. Now, the government most recently in the Department of Innovation have, I was supposed to say Jobs, Enterprise, Innovation, but the title has now changed recently. We need a policy to look at Industry 4.0. We need to have very strong industrial partnerships. No one company can do it on their own. We need joined up thinking with the research community. We need a program of R&D to help the manufacturers. We need incentives. In the Italian case that I mentioned earlier, in Italy, they have got incentives now to help companies transition, particularly brownfield sites. Companies that have already invested the infrastructure from 10, 15 years ago, they won't be able to rip that out. They need a different way to try and get themselves connected, so how are they going to do it? And we need help when it comes to the whole training side of it. There needs to be a significant change in some of the skill sets that our students are being taught within the colleges, and their employees that currently, as they exist today, need to learn new skills. Our organisation is supporting this with the government agencies and our academic partners through the technology enablers that I mentioned some of them there earlier, and the pilot sites and the test beds. We've got a new facility which we're setting up in Mullingar. We've got over 150 companies engaged in the work that we're doing. We've 40,000 square feet available to us down there for research pilot lines, innovation rooms, industrial collaborative workspace. And it's less than a 3-hour commute for most manufacturers in this country. We have no traffic lights between our office in Dublin and in Mullingar, so it's an effortless drive from any of the main cities around the island of Ireland. So there's no excuse as to why you can't connect in with us, and up and down in a day. This pilot line that we're facilitating is going to cover 3 different particular areas: additive manufacturing, collaborative robotics, virtual reality, augmented reality cave, and Industry 4.0 pilot lines. There's a photograph up there, as you can see it. It's called the Mullingar Life Sciences Park. In fact, its previous function was a cigarette factory. It's great to see it's no longer a cigarette factory, now it's going to be a life sciences park, so it's going to make people healthier, thankfully. And we're taking over the building on the right-hand side. There are 3 halls there over on the right-hand side of that big white square or piece that you can see in the centre of the photograph. And you can see an image of it over in the right-hand corner there, the layout or the plan. The first hall, you can see it's generally built into 3 halls there. The first hall is just finished. It'll be open now in the next 3 weeks. We'll have additive manufacturing in there and a little bit of collaborative robotics. And then the other 2 halls we will facilitize out with industrial pilot lines over the coming year. And that's my talk. Thank you.
Okay, just hang on for a second. If you want to take a chair over there, we'll take a couple of questions. While our speakers just get sorted out, our next event, our next next event is on the 4th of December, where we have the IMechE president come over to give an annual lecture, and we'll have a kind of a reception to mark the occasion. So first of all, is there any questions? Does anybody have any questions? John, sorry. Yep, at the bottom. Yeah. Just press it at the bottom.
At least the light is on.
Do we have a second microphone? I have 2 questions, one of them for Barry. I don't quite understand what co-biotics are, and you might explain that to me. And the second question for Eberhard is, as I read about Industry 4.0, the intention obviously is that the whole feedback to the manufacturing process should go far past, we'd say, the wholesaler, retailer, into the use of the product, giving feedback on its life performance. Is the plan in Germany at present only focused primarily on just reaching the customer being the manufacturing company, say a car factory, or does it extend on to the customer phase, the public phase? Does that make sense?
Now I hope I got the question right. There is plenty of aspects how you can use the communication of devices or of intelligent products in the future. And my focus when I was speaking was in the production environment, that if we have feedback from the machines, from the sensors, that we can optimize the systems by using this data. So this is one of the aspects, and that we then can establish quite well predictive maintenance concepts, watching what is going on in the machine and avoiding downtime for sure, improving the OEE, but also learning by software packages, as you mentioned, which helps us understanding better a situation and then improving the overall situation for upcoming new designs, for example, or also learning on how to improve existing machines. That's the production aspect. If we sell products to end users, for sure we can get other information back, thinking about intelligent textiles, if we have sensors in our textiles in future, or in many, many other consumer products. There the feedback loops can be completely different on how to not only improve the product itself, the textile or what else it is, but also the logistic processes, the point of sales perhaps. And also there is an opportunity, as you have mentioned in your slide, some of these disruptive technologies or young companies who game changed things like the hotel booking or the Uber taxis. If we have a chance to have, as a manufacturer, direct access to an end user by bypassing retailers, for example, or making new business models, there might be really game-changing things. Also some threats, as well. So depending on in which business we are, we have to take care of what's going on. Yeah? Also we as a Festo have to take care. Yeah? What is the Amazon doing? Is the Amazon tomorrow selling cylinders? What does that mean for our business? Which is the value we can add to our products that Amazon perhaps cannot add, just to take brand names, just to illustrate it a little bit. So this is very much depending on the business you are in and the intention you have to follow, which kind of information you want to feed back and for which reason.
But just to clarify, at present, the national plan in Germany, the plan that you have for Industry 4.0, it's primarily focused on the manufacturing world, is that correct?
Yes, that is.
Thank you.
John, just on cobots, it actually stands for collaborative robotics, and I had a slide, but as I said to you earlier, I had a team who pulled a bunch of my slides for this evening. It's where robots actually work side by side a human being, and where typical today, the standard with robotics are that they have to be behind a cage, and they're deemed to be quite dangerous, or can be. So the question becomes, can you have a robot that will sit side by side and help a human being do some very dexterous tasks or reduce ergo strain in kind of work that they're trying to do? And if they are, then you need to make sure that these things can work safely. And so that you need to have a lot of sensory power and perception, and know that in fact, you know, it's not a pen that's lifting up, that it's a finger that's in the way, for instance. So there's these systems, as we heard earlier, are just kind of coming to the market now, but there's still a long way to go, both from a standards point of view to make them safe, or to be approved by the bodies that they say that it's safe to be used within manufacturing facilities. And in order for that to happen, we're going to have sensory power put onto them in a way that hasn't been done before. And then we also have to work on the whole psychology side of it as well. Will human beings be comfortable working side by side these type of robotic systems? So the research that we're doing is looking at that as well from a psychological point of view. You know, what is the best way for human beings to operate with them? And there was a great example of that recently. I saw at the Young Scientist competition with two young brothers. One was in 5th year and one was in 6th year, and they built a robotic control system for, effectively was a home automation system for their grandmother. And there was one guy who was the real techie. He delivered a fantastic solution. But when they put it in the grandmother's home, she never used the, she tried it once or twice, and then it kind of didn't work, and so she kind of gave up, and you know, her grandchildren. So they came in very disappointed. He couldn't understand the reason why. The second brother kind of copped on what the problem was, and so he went off and he got a tablet, and he put an emoji on it, and he put a smiley face, a straight face, and a sad face on it. And so that when grandma made an instruction, if the robotic system didn't understand it, it gave a sad face. And grandma's utilization of the system went up 87%. So it was great to see, you know, even young kids kind of copped on to realize actually there's this whole psychology side of this thing here along with the robotics side of it. So that's the kind of work that we have to do within this country to make these things work.
Yeah, just behind you, John.
Thanks very much for the very interesting talks. Mark McGrath from DIT. I was just wondering from the German perspective, how the third level colleges and universities have reacted to the imminent onset of Industry 4.0, and how much collaboration there is between the companies such as Festo and SAP and Siemens and so on, and to any extent does that collaboration involve you facilitating them with physical resources or equipment to help to equip the graduates of the programs with the skills that they're going to encounter when they go out into the workforce?
Yeah, I mentioned briefly that our Festo Didactic business unit, this is an independent business unit, they have different roles. One is in the discussion with the German government, make sure these job profiles and job changes are discussed there on a countrywide side. And when it comes to an implementation in schools, that's a little bit specific now in Germany. We have these different implementation strategies in each region. So the local government is doing the implementation also at the university level. And we are helping now with these kind of cyber-physical factories, for example, the schools or the universities, to train their students. And now this depends a little bit on the philosophy the local government is following. For example, in the area where Festo headquarters is located in the southwestern Germany, the local government spent 8 million to implement these kind of cyber-physical factories into 11 universities, just to make sure they have the very advanced position for that area. And when I explained that example, for example, to Austria, I had a political delegation from Austria. It was a special area in Austria. The guy immediately jumped up and said, that's exactly what we also need. Making sure your people are educated, and this is something which needs a strategic invest. Festo will not always give that equipment out free of charge. This is how we cannot survive, at least not for the moment. But we're helping each other. This was the other part of your question, in these industrial associations. If it is a standardization organization looking after IEC or what else standardization, this is part-time work of some of our people and also from Siemens and SAP and others, where the companies invest and try to agree to standards. In other corporations, for example, if we would like to feed our data into a Siemens MindSphere cloud or into a Rockwell factory talk or what else it might be, there it is a company bilateral discussion, and there we try to agree on gentleman agreement or win-win situations for both and for all of our customers. And this is what's going on now as a discussion, for example. How do data from a Festo cloud fit into a Siemens or Allen Bradley or what else environment? There are many clouds now coming up. And this is also an area where we invest, where people are busy on, and where these companies also try to sort out which kind of business models do we want to support tomorrow. Yeah, I mentioned that there's the need for trust in between these companies. If everybody wants to earn millions of euro, it might be too expensive for the end user at the end of the day, whether it's in Germany or Ireland, doesn't matter then. And we have to come to fair business models so that everybody will be able to join a win-win situation. Yeah. And many things are still to be discussed. There's not everything ready. So we are in a relative early starting position, I would say. Did I catch your question?
Yep,
or
thanks very much. Yeah.
Yeah, just in relation to that, like since we're kind of academics, do you see particular skill sets required of engineers now? Like, I mean, you talked a lot about the OPC UA standard, so that's a like a telecommunication standard that wouldn't be familiar to like mechanical engineers. So do you see that as an aspect maybe lacking in kind of traditional type of mechanical type of programs, education programs?
Yeah, we think that this is indeed a changing part. We had the last professional changes from the mechanical engineers to the mechatronic engineers, combining electronics and mechanical things. And I think this will now continue. These cyber-physical systems will bring us into a situation where all design engineers have to understand communication in the product, because we will see many, many more sensors upcoming with microelectronic technologies, with biotechnologies perhaps one day, and even more, bringing us into the opportunity to bring in more sensors into our products, whether it's textiles or perhaps one day food or one day other products, not only machines. Yeah. Then we need the people who understand what's going on there and how to design that and how to make best uses out of that, investing in the right sensor technology and not in the wrong. And therefore, these professional pictures will change and the roles will change. And later on also for the maintenance people, for the operating people of these complex machines or these collaborative robotic systems, these will be different. If your machine has 400 IP addresses and a server room blinking strongly, that is very different to operate than what he did yesterday.
If I might have just add to that, there certainly is a critical skills shortage of a lot of emerging new thematic areas that we're seeing. If I look at in manufacturing facilities today, where PLCs would be, the norm, as that's changing to embedded microcontrollers and this whole convergence between the OT world and the IT worlds, there's a real need for retraining for operators who work in manufacturing floors, who've worked at those traditional PLCs, to look at now embedded microcontrollers, because there's a transition point happening now, and they need to get skilled up and trained up. We need to make sure that our graduates who are coming out have got the competence actually on both sides as we're crossing over. And so that needs to be looked at. The whole area of robotics needs to be looked at. It hasn't been looked at in the way that's needed, certainly with this country. I know within other countries, in Germany, it's certainly been, it's got a higher profile. The area of additive manufacturing, for instance, and that's an inflection point now for manufacturers. When we've such a density of manufacturers here in this country, and with additive manufacturing being one of those seen as being inflection points for manufacturing, we need to have our graduates coming out with those kind of competencies. And there's a list of others as well. So I think the traditional degree programs as they exist today, I think there's a need for a much more versatile and flexible programs being introduced to keep up with the rate at which these technologies are being changed.
Sorry, can I just follow up very briefly on that? Sorry, it's Nigel Kent from DIT. I was at a talk earlier in the summer, a guy from Siemens talking about the digital factory, I'm glad you mentioned it, Barry, because he kind of sounded the death knell for PLCs, and I was surprised that a guy from Siemens would do that. And then I was kind of, I guess, heartened to see that you spoke about PLCs in your own talk. So I'm just wondering, from a Festo perspective, where do they see the future of PLCs? As opposed to the move to embedded, because the Siemens guys were not so much that we're finished with PLCs, but he definitely sounded the death knell.
Okay, if you think the trend towards decentralization to a lower end, we see that more components of today, partly mechanical components or mechatronic subsystems, will have the intelligence to organize themselves. And if that trend is one of the visions and will be stable in Industry 4 environments, the role of an existing today PLC will definitively become smaller. They will perhaps manage batch sizes or something like that, but they will no longer have the role of controlling each movement in each machine at any time, but to delegate, and these subsystems are organizing themselves. If we come to the point, but we don't know whether that happens in the next 10 years or not, that these subsystems talk to each other, and the vision of the factory, that the workpiece is traveling in and calling to the factory, here I am, now treat me well, and it knows what it has to be done, and it organizes its way through the factory itself. We are far away from such a situation, at least in the real factory outside there. Perhaps some laboratories have some first ideas. But in the long term, we expect the role of traditional PLC will decrease for sure. It will not be in 3 years' time, and perhaps not in 10 or 15. Yeah, this is a longer going process, as the industrial change with the steam engine took also a couple of decades. Yeah, so this will be a long-term change. But this is why Festo is, for example, preparing ourselves with the decentralized control, and we are investing a lot of money in that strategy, because we believe these cyber-physical systems, next to the mechanical actions, are better to optimize a motion process than a controller sitting meters away and coming from a manufacturer not knowing the mechanical things going on down there in the shop floor. So we'll see a good competitive position for those companies who are able to manage the mechanical processes in the machines, and that's why we invest a lot of research and also money into that direction to be well established in that place, and helping our customers to be engineers of productivity also in the future together with us.
Yeah, I come from the building energy management controls system environment. And we've got a lot of different protocols that we're working with at the moment. The KNX protocol for lighting, we've got Modbus protocols, we've got BATnet protocols. All of these are quite problematic for us to interface. Moving forward to where you are now with IoT, how do you see that sort of siloed structure breaking down, and how do you see protocols starting to integrate so we get a complete merging of systems?
There was a famous speaker in the 60s. He started a famous speech with, "I have a dream." The field bus people who had pain like you, and Festo is also one of them, because we supported more than 26 protocols in the early days of field bus technology, were painful early years. Then we had the trend towards standardization of field bus technology. We all had been happy, okay, it will be only a couple of field buses tomorrow. It didn't happen like that. Then we had coming up the industrial Ethernet protocols. Again, lucky situation, the one and only protocol tomorrow. No, we have 7 industrial Ethernet protocols minimum. Okay, it's better than 26, but still not the optimum. And honestly, our assumption is that also OPC UA will be not the one and only standard. There might be more, and the world is big and these things are changing quick. But we believe that we can better implement the more we agree to standards. Now, we are not in a socialist country, and the world is not perfect, and we have a lot of competition, and there's a lot of elbow coming out if you try to standardize. And the CAD software I mentioned, this AML standard, is one of the big things, is the competition now. If we want to standardize that, there's a lot of CAD software manufacturers, and the same happens now in the field bus world. There's a big supplier coming from the south of Germany. There's another big supplier in the US. There are other big suppliers in Japan. They all try to protect their business. That's normal, pretty normal in a competitive environment. And we have to argue from the end user's point of view, that standardization would be a great thing because it gives us flexibility and it makes our life easier, for sure. And we expect that the big end users, like the automotive guys or other big end users in pharmaceutical industry or many others, will take their end user power to influence towards more standardization. But it will take a while. It will not be ready overnight. And yeah, this is, I think, the reality. It will take a while. I'm not so sure I'm retiring in roughly 15 years. What is the situation when I retire? But it's, I think it's on a good way, but we're still not perfect. We have to work hard to get better standards established, and we hope that OPC-UA is a good candidate, not as a field bus technology, it's just a communication protocol on top of these, just to be sure on that, and we will see how that will develop in the future. I have no clear, very perfect answer on that. You anything to add?
No, I totally agree. I think that would be the aspiration, for sure, and to do the same thing with industrial IoT as happened with the telecoms industry. But it did happen in the telecoms industry. It's pretty much a seamless thing where, you know, you can make a phone call in this side of the world, and you know it seamlessly is picked up in the US, and you can bring your phone across to the US, and you can work over there. So that, you know, they figured it out in the telecoms industry, and the question really becomes then, what's the challenge now in trying to bring that right back into all these other industrial protocols that exist in there, and how easy would it be to standardize, and what's the willingness, I think, really of the industrial base to go do it, you know, to see the market opportunity, because you know, as has been said earlier, the companies will protect their market position and won't want to make the change. So, but I think legislation is going to push some of that forward. I mean, I think things like serialization in the pharma and the biomed industry, where track and traceability of parts is a legal requirement, is going to drive certain behavioural changes that will force standards to have to become standardized across, if you like, the entire supply chain. So it certainly, I think, will simplify, but I absolutely agree it's going to take a while to do that.
I think as a business we'd welcome it, but it's for a small manufacturing company, it's very difficult when you don't know where the end is going to be. It's going to be expensive to get there, and it might mean that a lot of small companies actually drop out of the game.
I think Barry's point there, where you have like some standard industry like pharmaceutical, like driving out requirements, say on the serialization as you described it, but also I think the other thing is data protection. You know, there's different rules and regulations, say within here in Ireland, you know, because of Europe, etc., and also America. Then, in terms of if you just look at the general data thing,
I think that's
a lot of network issues, I think, haven't resolved that data security problem, and so that might again cause a weeding out of things. Like, I mean, somebody described it to me as it's like a Wild West situation where you have loads of like different standards being trotted out, and they're all trying to gain market share in order to ensure their basic like future. And so I think there will be a weeding out of things. So it's tough. Sorry, question?
I'm reminded of Semtech in the semiconductor industry, which is all the industry came together to funded and defined their interoperability standards, so lots of competitors could compete and contribute to manufacturing lines in the semiconductor industry.
Any other questions?
Rory Williamson from Fluke Digital Systems. It was interesting to see that both Ireland and Germany were, I think, a front runner or a leader in IoT technology or adopting Industry 4.0 technology. And I was just wondering, maybe from both an Irish and German perspective, what do you foresee, or what do you anticipate to be the most adopted or Industry 4.0 technology in Ireland in the next 5 years? And then maybe the same question then for Germany, just to get a comparison.
Well, I think the one that's been talked about is OPC-UA has been the standards that you know, I think Ireland will follow what the European Union are doing, and the leadership for that has been set out of Germany. So I think in terms of a standard that, you know, as I listen to people talk about the connected factories, what standard do they talk about most often? That's certainly the one that features.
I think the rest of the question is a little bit difficult to answer, because the next 5 years is relatively close by. We see some strong initiatives in the automotive industry, for example. They pushed in the last couple of years this so-called AIDA standard, at least driven by the German automotive industry, which forced the Siemens and so on to follow a specific implementation. We know from some discussions there that they try to establish a communication standard how they would like to implement these Industry 4 technologies. This could be a strong influencer, at least for that area of the industry. We see in other industries, like electronics industry, there's also some discussion started. And interestingly, regarding the cloud concepts, there is also now a little bit of game changing. We know there's the big players already in place with Rockwell and Siemens and SAP HANA and some other clouds. These cloud concepts are now a new technology, which is where we have some interesting discussions how we would like to implement that. And we now see that many industries try to establish their professional cloud for the whole business, like woodworking industry or machine buildings industry. And this is an interesting discussion now, because is every machine builder establishing his own cloud, or is a group of machine builders in Germany, in Ireland, in other countries establishing the one and only machine building cloud here? And what does that mean for the competition in the country? Are the competitors willing to join such a competitive cloud with their neighbors? And we see some interesting discussions here coming up, and I would expect that these cloud connections is one of the big things we will in 5 years, how these cloud concepts will be implemented and how one cloud can talk to another. I didn't mention in the speech, but we are preparing ourselves, for example, to be a partner also in different cloud concepts. So if somebody in a Siemens cloud or SAP HANA cloud has a pneumatic question, he can send the data live to a Festo cloud, asking for the expertise app and getting a result back. And then from the end user's point of view, there's only one cloud and one billing system. And the clouds, if they have 10 questions to other clouds, they make the external billing independent from the end user. So these kind of concepts we expect will be defined and established the next 5 years. OPC-UA for the moment is the agreed standard. Whether there might become a new one with MQTT or something like that implemented into the devices depends a little bit on the industry. That's too early for me to say what's coming on there. And we expect that more decentralized intelligence will go into the mechatronic subsystems also in the next 5 years for new machinery, because that's a strong trend we see in our business environment, and there's a lot of benefits for the customers to have an easier plug-and-work implementation if they follow such a trend. We are one of the partners. We are not the only one in the world, but we are happy to help our customers, whether it's in Germany or in Ireland, to go that way.
Okay. Any more questions? I think we're done. Okay. First of all, I'd like to thank our two speakers. Fascinating talk. Somebody once asked me, like, what's the function of the committee? And I came up with that we are like John the Baptist, kind of like a voice in the wilderness, in terms of trying to kind of promote future trends and trying to draw attention to new avenues for, especially for Irish industry and that sort of thing. So it's great that we can actually get people together and kind of have a really good discussion. I thought some of the questions were really good. So anyway, you're welcome to attend the next event, which is next booked event is basically 4th of December. I'm Mickey, President's address, and I'll close the meeting. Thank you.